Okay, so today we're going to go over 3.4, which is how to graph functions. If we look at example 1a, we have negative x plus 2y equals 6 for our domain of negative 4, negative 2, 0, and 2. Okay, if we remember, our domain is always referring to our x values, so I know that those are my x values that I'm going to graph. Second thing that I need to know is that I cannot graph an equation unless I have it solved for y. Okay, so I need to solve this for y. So how do I get rid of a minus x? Add x and add x. Okay, then I bring down my 2y. So I get 2y equals 6 plus x. I cannot combine them because they're two different things. Okay, so then how do I get rid of this 2? Divide by 2 and divide by 2. So I end up with y equals 6 plus x divided by 2. Okay, you have to do that if it's not solved for y, then you have to solve it for y before you can graph it. Second thing then that we're going to do is we're going to make a table of values. Okay, and I have the x values negative 4, negative 2, 0, and 2. Those are my domain values. Those are my x values. So that's what I'm going to plug in for x. So if I plug in negative 4, I get 6 plus negative 4 divided by 2. What's 6 plus negative 4? 2. Okay, and what's 2 divided by 2? 1. So my first y value is 1. If I plug in negative 2 for my I get 6 plus 2 divided by 2. What is 6 plus negative 2? 4. Okay. And what's 4 divided by 2? 2. So for my second y value, I get 2. If I plug in 0 for x, I get 6 plus 0 divided by 2. 6 plus 0. 2. 3. So 3 is my third value. If I 2 x plus 2 divided by 2. What's 6 plus 2? What's 8 divided by 2? 4. Okay, so these are my y values and x values that I'm going to graph. 4 tells me I'm going to be going back on my x-axis. So I'm going to go back 4 on my x-axis. Then that 1 tells me that I'm going to go up 1. So back 4, up 1. If I look at 2, negative 2, 2 tells me to go back 2 and up 2. So there's my second point. 0, 3 tells me to go over 0, up 3. And 2, 4 tells me to go over 2 and up 4. So I end up with points that look like that. Once you've got your those points plotted, then you're done with this one. Okay? So let's look at another one. So we've got f of x equals the absolute value of x. And it tells us that our domain is negative 2, negative 1, 0, 1, and 2. So I'm going to graph this for x and y. This is already solved for y because this is like y equals. Remember I told you f of x and y were basically the same thing? So this is like y equals the absolute value of x. X value, so our domain is going to be negative 2, negative 1, 0, 1, and 2. Okay. That tells me what I'm going to be graphing. So then if I plug that in, then I get the absolute value of negative 2. And absolute value to positive, so this becomes positive 2. Plug in negative 1. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. Perfect. So then if we go to negative 2, 2 tells me to go back 2 and up 2. Negative 1, 1 tells me to go back 1 and up 1. 0, 0 stays at my origin. 1, 1 tells me to go over 1, up 1. And 2, 2 tells me to go over 2, up 2. So I end up with a graph that looks like a V. And you should get a graph that looks like a V for absolute value. You either get a graph that looks like this for absolute value, or a graph that looks like this for absolute value. Okay? Alright, so if we look at example 2a, we're given the function 2x plus 1 equals y, but we're not given any domain values. Okay? When that's the case, then we get to make up our own domain values. Okay? And we generally like to stay with small domain values. So why don't you guys give me some small domain values that I can use? 1, okay, and 2, 4, and 5. Okay. So we're given 1, 2, 4, and 5. So those are the values we're going to use to graph. So if I take 1, I'm going to plug 1 in for x. So 2 times 1 plus 1. What's 2 times 1? 2 plus 1 is 3. Okay. Plug in 2. 2 times 2 plus 1. 2 times 2 is 4 plus 1 is 5. Perfect. If I plug in 4, I get 2 times 4 plus 1. 2 times 4 is 8 plus 1 is 9. And if I plug in 5, 2 times 5 plus 1. 2 times 5 is 10 plus 1 is 11. Okay? So I have my points if I'm going to graph. So 1, 3 tells me to go over 1, up 3. 2, 5 tells me to go over 2, up 5. 4, 9 tells me to go over 4, up 9. And 5, 11 tells me to go over 5, up 11. Okay? So then, since this did not give me a domain value, now I have to connect my points. Okay? When it gives you a domain, you leave it like this, a discrete graph. But when it doesn't give you a domain, you have to connect it and make it what type of graph? What type of graph do we call? Continuous. Perfect. So when it doesn't give you a domain, you need to have a continuous graph. So you have to connect your points. Okay, so we just draw a straight line through our points and then we're done. Okay, so let's look then at my example y equals x squared. We're not given a domain, which means we get to pick our own. So what are some values we want to use? Niles, what's a value you want to use? 1, okay, and Kyle, what's the value you want to use? 3, Ethan, what's the value you want to use? 4, and Connie, what's the value you want to use? 2. Okay, so we get 1, 3, 4, and 2, so we're going to plug those in. If I plug in 1, then I end up with 1 squared. 1 times 1 is 1. Okay, if I plug in 3, then I get 3 squared. 3 times 3 is 9. Okay, if I plug in 4, then I get 4 squared. 4 times 4 is 16. And if I plug in 2, then I get 2 squared. 2 times 2 is 4. Okay, so there are my points. So now I get to graph them. So 1, 1 tells me to go over 1, up 1. 3, 9 tells me to go over 3, up 9. 4, 16 tells me to go over 4 and up 16, so somewhere up there. And 2, 4 tells me to go over 2 and up 4. Okay, then if I connect my points, then I know that I get something that looks like that. Right? It's kind of got a little curve to it. And that's because usually squared graphs either look like this or look like this. So we just have the 1/2 of that. Okay? Alright, let's do 2 more, and you guys can get started on your assignment. Alright, so again, f of x equals 3x minus 2. And remember, f of x is the same thing as y, so this is like y equals 3x minus 2. So we're going to make a table of values. Okay, I can use any number, so what numbers do you guys want me to use? 3, okay. Niles, what do you want me to use? What? You want me to use 100. So it's small numbers. Okay. 5, okay, and Ethan. 2. Okay, so I get 3, 1, 5, and 2. So those are the numbers I'm going to plug in. So if I plug in 3, I get 3 times 3 minus 2. What's 3 times 3? 9 minus 2 is 7, okay? Niles, this was your number, so you're going to walk me through this one, okay? So 3 times 1 minus 2. What's 3 times 1? 3. 3 minus 2 is perfect. Okay? Alright, Kyle, your turn. 3 times 5 minus 2. 3 times 5 is 15. 13. Perfect. And Ethan, 3 times 2 minus 2. 3 times 2 is 6 minus 2 is 4. Okay, so we get our numbers. Now let's graph them. So 3, 7 tells me to go over 3 and up 7. Right? Okay, 1, 1 tells me to go over 1, up 1. 5, 13 tells me to go over 5, up 13, so somewhere up there. And 2, 4 tells me to go over 2, up 4. Okay, now that we have all of our points plotted, we connect our line, and we end up with a continuous graph. Okay, we've got one more type of problem that you guys are going to do on your assignment, and that's when we're going to evaluate functions. And this is something we've been doing for a while, and something just every time we graph. So, when we're using f of equals 1/3 x plus 2 to find x equals 6, that tells me that I'm going to plug in 6 for my x values. So I end up with f of 6, which is the same thing as y, so we ignore this side of the equation. 6 plus 2. And what's by 3? We're multiplying, so this is like 6 over 1, so this would be like 6 over 3, which is 6 divided by 3 is 2. So I end up with 2 plus 2. And what's 2 plus 2? Perfect. So f of 6 is actually equal to 4. So when you're given problems like this, all it wants you to do is plug in your value. We're not doing any graphing on those ones. We're just finding our value. Okay, so you guys are going to work through page 190, 1 through 24.